Okay, now we are going to go through what we have done over the last 4 weeks. We have covered the chapter 5 up to the Gram-Smith orthonormalization process, and we have covered chapter 6, uh, eigenvalues and eigenvectors. I gave you the content and offline lectures as well. And on chapter 7, we have covered the general vector spaces, which is the real vector space from the basic knowledge of vector spaces on uh, real vector spaces over the real field. In chapter 7, you have gone through most of the similar knowledge of the vector space over the complex field. One of the important part of chapter 7 was the inner product space, which is an example of a vector space that has an inner product in it. If any inner product can be defined on a given vector space, then it is called an inner product space. And isomorphism section covers if you find an isomorphism between two vector spaces, then we call those isomorphic. If those are isomorphic, then it preserves the vector addition and scalar multiplication. That means most of the proof that you have had can be applied in the any isomorphic vector spaces. So all of your knowledge on a vector space can be applied any vector space which is isomorphic to the one that you already knows. So this makes all of your knowledge are useful on vector spaces. If you know one example of vector space, and if you find some other vector space that has a isomorphism between those two vector spaces, then you don't have to study both. You can use all of the knowledge that you found from one given vector space to the other one. Okay? And there are some special matrices, and singular value decomposition was covered. And in chapter 8, it was a quadratic form and application of quadratic form. This used to be a very important part of the linear algebra, but most of research was done on it, and you can use the fact which was proved already. This is a generalization of finding relative maximum and relative minimum, not by using the derivatives. You can use your knowledge on eigenvalues and eigenvectors to get the same result, not for the two-dimensional or three-dimensional function, the matrix, which means the function of two variables or three variables. But you can extend it to any function of as many as the different variables, which is similar to that size of matrices and eigenvalues and eigenvectors. So if you know the eigenvalues and eigenvectors, then you can easily find the answer for the given problems related to the relative maximum and relative minimum, and many others as well. And here, as one of the example, I showed you how to find the singular value decomposition of a given matrix. From here, you found what pseudo inverse by using the singular value decomposition, and also you found a way to get the least square solution easily with the pseudo inverse, which was derived from singular value decomposition. Okay, so that was covered in chapter 8. And chapter 9 was the Jordan canonical form. As I mentioned earlier, the Jordan canonical form is a kind of the most simple form of a given matrix that you can derive the most of the result for the original questions. So if you are able to find the Jordan canonical form, then you don't have to deal with the original large complex matrix. Then you only need to handle the the block diagonal matrix, which has only eigenvalues and ones and zeros only in it. So most of your computations are much easier, and your theoretical approach to show anything will be very easy with this canonical form. So what you are supposed to know is the definition of Jordan canonical form and the algorithm to find the Jordan canonical form, and you should be able to actually find the Jordan canonical form of the given matrix. After you find the Jordan canonical form, you can easily find the generalized eigenvectors, which makes invertible matrix S. That makes S inverse A S is equal to the Jordan canonical form of A. In that case, you have all the information of A and J and S. So you can with all those information, then you can do whatever you like to do, not only for A but also for J. So you can go through it. And now, we are in chapter 15. So here you will explain the problems that you have solved and what you have learned from this course. And I have added some of the information for you to read. Now we go through the chapter section, our BBS. I have some of you. Mr. No Hyun-woo gave us some information on computer graphic and visualization of matrix theory concept, and on GeoGebra here he added the contraction and dilation, the GeoGebra tool that explain the contraction and dilation and compression and expansion and shear and reflection and rotation, etc. And we may take a look on this to understand. This was made by student. Yeah. What you found, Mr. No, from this? Mr. No Hyun-woo, who is one of your classmates, made this. So if you move this theta, then you see how these rotations made. When you have a matrix, if you have a different matrix, then you will see how it changes. Isn't it? Like if you make this one to 0, then you will see. So this makes a nice and easy simulation of the linear algebraic concept. Okay, he made all this. Then you have to mention that what you had. But actually, I have made many of these already here. Okay. Here there are visualization of concepts in linear algebra and on vector addition and scalar multiplication and solving linear system of equations and matrix product and finding the area of triangle and rotation and linear transform shear, symmetry and rotations and etc. Okay, here. And also the projections and the least square solution all was made. So if Mr. No, if I were you, then I would try something that was not done. So that's the research. You have to do search for the ones that already done first. That should be your starting point. Okay. So you didn't do research. You only did what you like to do. But that's all that. But that's important. But if you are smart enough, then you better do. If you want to be a researcher, then you should do search first before you do something. So, we may take a look on one of the example, which is this. I made some explanations here as well. suppose we have these 3 points, then we can think of a triangle, which is like this. Then the area of the triangle that made by these 3 points can be found in this way. But if we change the number, then see, the point has been changed, so the area of the triangle also changes. You can see like this. So you don't. These can be done because this area is the one half of the determinant of a matrix which is made by these 3 points. If you change these numbers as something like this, then you have the different uh, different is two. Then you will see other triangle. Then so you can make a interactive change by just pointing out this, or you can just give the uh, the number, the point by yourself as well. Okay, so there are many things you can do. You can find the least square solutions as well. And yeah, there are many. So you are looking for a least square solution. If you change this number, then you will see how it changes. Okay, if you have a different point, then you have a different least square solution, which is has the smallest error of 2 norm that passes through, not passes through, but which is most close to these 3 points. Okay, so you can do such things, and shear as well, and symmetries as well. Okay, and not only for that, I made this is by Sage, but this is done by GeoGebra, which is very nice to use it. But you cannot go further. You cannot go for 4-dimensional or 5-dimensional problems that you see from the textbook. Okay, so we need another tool. That's what we made. This is a visualization of the. Here you will see many. Here you can see the many visualization which was done by Sage. And here this shows the. This shows. Yeah, this shows the same thing. Not it's the this. Okay, here let me explain. Here, suppose we have these 2 points, then you can find the projection. Here is the explanation of those. If you change these numbers, then you have a different vector u and v. Then you have a different projection value, and those vector u, v, and w, as well as the projection p, can be shown in this graph. You can make a change in the size of the matrices as well. So a lot more things can be done here. So suppose we are looking for the equation of the plane that passes through 3 points, then this can be done by this. As you see here, like what you saw, how to find the vector equation of the plane from the given point, you can also find the application of making colors, RGB colors, or a linear combination of the given vectors and how it changes. And also there are many more. For the matrix, you can find the volume of parallelepiped or area of triangle and the changes of the image when you multiply the matrix. And also you can see the linear transformation. You can visualize the linear transformations on many things: rotations and reflections and projections and dilations, and even for those. I may show you this or Mazinga Z. Then if you learn this, I made the graph of those images by this command. What's the risk? I don't need this. Okay, we learn it. Then you will see how the image of Mazinga Z and yeah, you will see. Yeah, yeah. So here, these are the command. These command makes those the image of the Mazinga Z or the pig, and then this command makes the rotations and dilations to make the changes on the image of it. So you may just go through those, and there and not only for that, there are matrix calculators here. Here, this is a okay, I will show it. Okay, so when you face such a problem that you encountered when you use the Internet Explorer, then you better use Firefox or Chrome. If you goes to, if you use this address, web address, and make a copy, then goes to the Chrome, and then if you paste it, then you will see the same page like this. Then you can, these are the commands for what we like to do. And this is the size that you like to make. You can always make a larger matrix of your choice. Then you can run it. Then you will have a 3 by 3 matrix like this. Okay? Then you can also this was randomly made. So you can make a change of any. Then you choose A and suppose let this one is -6. Then you can what? You can find the rank of, you can make A plus D or A, you can make A plus D matrix. And this is A plus B matrix. Then you can find what? Rank of this matrix D. Then rank is 3. And what else? Then if you do the what? Trace, if you find the trace, then the trace comes out like this. If you find the determinant of this matrix A plus B, that comes out like that. If you find the adjoint, then adjoint comes out this. And characteristic polynomial and eigenspace, so eigenvalues and eigenvectors, eigenvalue and its corresponding eigenvectors with algebraic multiplicities. Then if you find the LU decomposition of this matrix A plus B, or you can do the A minus B or A plus B. Okay, then you have LU decomposition for A minus B, or you can do the A times B. Then that LU factorization or QR factorization of A B star, A B transpose, it comes out like this. And there are so many things that you can do. A star A star, and B star B, B star B. Then even though you have a rectangular matrix, then you can make a square matrix like this, A star A. Then you can do the LU decomposition or QR factorization on this matrix. Or not only for that, there are so many other things in norm, inner product. You can find the inner product and cross product projection and span, whatever. So these are all those things. These were made from this command. So you can copy all those command this to make your own, and you make it change. You can change whatever you like to do to what you have learned from here. You understand? Okay. Then we go back to the iCampus. You have seen many others like that. So you just take a look what I have shown here, and there are a lot more. That's not the all I have shown you. So there are some other tools. Here is all the command that I made, and there are a lot more. If for this ones too here. For example, Jordan canonical for opening new tab. So this doesn't work very well on Internet Explorer, as I told you. So you go through this, go to the Chrome like this, then you will see not only those commands, but also those explanations are written in Korean. So you know how to define your matrix and how to find the Jordan canonical form, and how to find the P times Jordan canonical form of A times P inverse. So you should check whether these two are same matrix or not. You can easily check those two matrices are same like this. So you can find the tens power of A by only multiplying finding the tens power of Jordan canonical form of A like this. So you can copy this command so to use it any of the Sage server over the whole world, not only ours. So if some server has a problem, then you can find all other available server to do your computation from anywhere. Okay. Also, you can find the explanations of those concepts uh, uh, from the given information. So all those information was shared already like this. Okay. So that's not the all. So here are some other. Here's the Excel graph that I showed you. So this is a single cell server. So for example, if you want to solve the linear system of equation, you don't even need to do log one. Then you just solve this system of equations. If you change the number or coefficient, okay, then you will have different solutions like this without any. And also, you can make not only three variables equation, you can make a larger size without doing nothing, isn't it? Here, and also there are there are lots of here you are doing. Yeah, there are published Sage informations, and also I told you you can find the source from where here. I will tell you. If this is the way of using your information. Suppose you want to find the Jordan canonical form of a given matrix, then you make a copy of this and go there. Go to single cell server. Then you have a matrix like this. Okay. Then next, you want to find the Jordan canonical form. Then you just make a copy of this command to go there. Then add it. Then you will see the Jordan canonical form of the matrix like this. Okay. Then next, you wanna check, you wanna compare this Jordan canonical form and works. Check whether what you found is right or not. Then you can check they are same. They are same matrix. So this 4 minus 1 1 and this 3 by 3 matrix is same as this 3 by 3 matrix. So you can easily check it. Then you can find the tens power of the matrix in here. Okay. That to do, so you now have the tens power of the matrix A. But this is not only for tens power. You can do the same for hundreds power of it like this. This work not only 3 by 3 matrix. It works for 4 by 4, 5 by 5, 10 by 10 as well. So this is a power which is different to the GeoGebra and any others. And it's much convenient to do so. So I believe now you can find a Jordan canonical form of a given matrix. So it is proper to ask you a question on final examination on the concept of Jordan canonical form, because you already know how to do it if you submit one homework pages. If you have done it through the Q&A by yourself, then most important thing is the concept and algorithm. You have to understand it. So I'll make the question to check whether you understood those concepts and definitions and algorithms first. Okay? There are a lot more. All those can be done in where? Okay, yeah, there are a lot more informations here, so you better take a look on it. Now we continue. I continue. Yeah, as I told you, yeah, there are a lot more informations in here. Then you can take you can take a look on most of the lectures that I have given on chapter 6, 7, and 8 here. And also you have a sample exam, sample final exam here. So you better take a look what kind of the problems will be asked to do so. But this year I will give you more problems on storytelling style, not computational skills. But I will ask you how to use the tool to find the answer from the mathematical equations. And so you should be able to use uh, uh, the sage command to do the computations. I will give some sample exams, uh, sample final examination to you with the revision on it. Okay, so now you can listen what I have talked on it on Jordan canonical forms, which is the last chapter.
자, 오늘은 8장 Jordan canonical.
Okay, okay, and also, yeah, you have other lectures which was done for the introductory linear algebra class. Did you see it?
자, Jordan canonical form 10장. Jordan canonical form. 먼저 Jordan.
So you should be able to use all those to solve the problems. Also, there are a lot more. There are informations on solving linear system of equation and LU decomposition and many others as well. And also QR and SVDs and power method and singularity decomposition. And I have given you some problems on GRE problems for linear algebra that you're supposed to know if you want to go study abroad. Then also I have given you some smartphone applications that you can download it. If you go here, then you will download this Android smartphone application for solving matrix series. So if you install it, then you will really do the matrix series computation in your hand. And there are some more. I also, if somebody has an iPhone, then this is the iPhone application that you can download it. And you can download the iPhone application of the one that we made to do so. Okay. So, and also here we have some more. This is a life of this is the website that I made for the foreigners who are planning to come to Seongyungan University to know a little more. And this is the way of direction to come to our department, our school. Here, next page, and if you go here and 15 or 16, then it doesn't even have the how to use the washer and air conditioner TVs in the guest house in our campus in English, because all of those machines were written in Korean. It's easy, it was written in Korean, so those are having a difficulty. So we all made this by ourselves to explain. Okay, and others. And your due date for the project and the PBL report is due on Monday 11 a.m. Okay, so try to keep the time. And also, here you will see all the solutions of those what we have learned. Most of the solutions for the problems and exercises. And we have done some more problems over this. So yeah, we will upgrade it. And I told you GeoGebra and Sage tools and how to use it. Particularly for this one, here, opening new tabs. And if you take a look on this explanation, then you will easily understand how to use it to do to fully to use the full capability of the Sage to deal with your problems on matrix theory and linear algebra. And I have graded some of the earlier problems for Miss Kim, and she will finalize all those problems for you. So you help Miss Kim to get finalized okay by me before this week, so you can submit your PBL report before Monday. Okay. And so the mistakes that you make are when you do computation by hand, and then you did you did use a computational tool to get the same result. Then after you checked all those, then you should give the conclusion, which was the answer that you was asked. So finding the determinant of A, then the last sentence should be the answer for the given questions. And if you do all those both methods to find the right answer, then you can easily expand your knowledge of understanding the algorithm for the larger size or general matrices. That's what our course intended. Okay. And for such problems, if you are asked to find the m by n skew symmetric matrix with the determinant not 0, then you can easily expand the matrix that you have to the m by n general matrix in this way. Okay. And some notation still you are mixing the notation, mathematical notations. Like this, you should have the right answer at the end, and without any typo in your answer. You should use the RM bold for vector. And when you use the English sentence, you should not make any grammatical errors. So I recommend you to use only mathematical symbols that has no errors in it to give an answers. So yeah, those will be done. So you don't have to worry to do it. And what else? Okay. In addition to that, I want to show one more things. When you remember the Professor Bob Beezer was here a couple of weeks ago. Okay, he talked about the matrix diagonalization for you. And during his visit for 4 days at Sungkyunkwan University, we have worked to write the English calculus book. This is the whole book from chapter 0 to chapter 15. This is the whole content of the calculus. So if you see this, then this comes with this calculus with Sage by us, and this has the content from the single variable calculus and multivariate calculus, from the limit and continuity and differentiation and application of differentiation, integration and application of integration and techniques and parametrifications and etc. and vector calculus and multiple integrals and things. I will show you a couple in here today. Let's see. This is chapter 14, multiple integrals and double integrals. You must have learned this, and you should be able to do these computations to get the answer like this. Okay? And there are some rules. Here, I will show. So you must understand how to compute this in a simple form by hand. So this can be done in a stage like this. So I will give you some problems which can be solved on this. So for example, okay, you should be able to draw the graph to figure out what's the meaning of your answers. So I will, for example, you want to find what? You want to find you want to draw the graph of spherical, you want to find the you want to find what? If you want to do, describe in words the surface whose equation is given. So look over what this equation means. You should, if you want to describe in word the surface of this equation, you should draw it first. You should have a graph, sketch of the graph of this function. This can be done with this command. I made all this command, and it has been uploaded on my website, so you can. Yeah, here. This is so here you can draw the three-dimensional plotting here without any difficulties, isn't it? You can move this to take a look, and you can enlarge it with this scroll. Also, this is not only one. If you can do this, you can make what? All the different equations which can be modified from this. You see the bigger cylinder. Okay? And what else? So you can now, after you play with it, you can explain what's the meaning of it. This is another tool. Then this is what? This is what? This is ball, three-dimensional balls. You can. So this equation, rho is equal to 4 means a ball with a radius 4. But now we have a ball with radius 8, isn't it? And you can draw all those without nothing. Your only thing is okay, etc. Anyway, this is not your. After you figure it out, you can solve. You can three-dimensional. You can really do the computations. This is the implicit graph proceeding. You can find when you want to find the triple integrals, or if you want to find the area or volumes of the given function. This is what you have learned before. Okay, but now when you solve it, if you want to find the integral, this value. So you want to do the triple integration of this given functions that you used to do it by hand. But now, yeah, you know how to do integrate it. Then you can get help from the server to do these double integrals. So I want to copy and do it at Chrome. At Chrome. Here. If you want to do those triple or double integrals, then you can easily find the answer like this. What do you think? If you want to change the equation like this, 4, or more complex, or even more complicated one like this, you can always get the answer. What do you think about this? Tell me. So you have seen what you can do with all those tools and computations. The reason that we are talking about this in this class is because all those most of our work can be can be done in really with the help of computer. But computer is a discrete machine. So all the algorithms and all the programs depend on the discrete mathematics, which is the matrix theory. That's all depend on matrix and understanding of matrix, understanding of the system of solving system of linear system of equations. Understand? So all of those basic ideas and things are from this linear algebra textbook. All those background idea of the computer algorithms are in that book. That's what you should understand while you are taking this second course of linear algebra. So if you understand those the theorems and proofs and its algorithms, and if you play with it in a simple form, then you can definitely be able to deal with the more complicated problems, which not only make the software for mathematics for the linear algebra. That's the starting. That's the origin of all tools for all diverse disciplines of mathematics. On calculus and differential equations and engineering mathematics all comes from the algorithms of matrix linear algebra. That's what you should know. Singularity decomposition and QR factorizations, LU decomposition, and those are the typical examples of those algorithms. Not only solve the matrix problems, that solve the all continuous problems and all real life problems. Okay, do you understand? And then the last, and you can easily search on what the finalized problems. I found many of you already get the finalized okay on the problems that you got involved. Some of you can make a team to clear up all of your problems today to finish up the draft, so you can finalize all your PBL report. And also, I think I gave one. No, so I made the homework box in this 과제함 box, so you're supposed to go in, and I uploaded the form of final PBL, so you may leave for this one. And what else? And also I mentioned that the first or the best, the one who submitted the homework at first, and the one who submitted your homeworks and project at the best status, those will get the highest point first, and all the others will be graded with compared to the highest one. Then the difference will be made from the best to the worst, and we will start to present your PBL report and your project from next Monday. So I will give the order. I will give you a chance for those who's done well, and so you will have a chance for your presentation. So keep your eye on after you submit your PBL report. So I will ask some of you can show you, because all of your homeworks will be here, so you can easily show it from next Monday. And also I'll make the evaluation form, which will be distributed to all, so you can evaluate the others' presentation and on project and the PBL report. Okay. Any questions? Any questions? Okay, then let's clear off. Class dismissed.